How's it going, everyone? Hope you're having a good day. Do you have any questions on 6.1 before we move forward? Okay. We'll go ahead and work on 6.2 today. And again, the next week, the plan is we'll review on Monday, and then on Wednesday, well, basically from Monday until Sunday, we'll have we'll have that interval for taking the test. But we will have Wednesday off next week just to give you an opportunity to take the test during that time. Anyhow, yeah. So, section 6.2. This is on the binomial probability distribution. And when we talk about binomial probability, this describes a situation where all outcomes can be classified as in two we can classify results as two outcomes, which we define as success and failure. So we classify the results of a probability experiment as either a success or failure. Okay. So essentially we have two outcomes. That's why we call it binomial. Bi meaning two. Because we only have two outcomes, one of the nice things is each outcome is the complement of the other. Okay. So, let's look at some terminology and some notation kind of simultaneously. So we said each experiment has outcomes defined as either success or failure. So the probability of success two C's in success, sorry. Probability of success is the value P. Now, probability of failure, we don't always have to express this, but I just want to make sure we're okay calculating it. Probability of failure is Q. Now, even though we won't necessarily be given Q, the way that we find it is by taking 1 minus P. And that's because they are complementary probabilities. So if we want to find the probability of the complement of an event, we take 1 minus the original event. Okay? Or 1 minus the original probability. Now, the number of times the experiment is repeated is called trials. Now we use the notation N to represent the number of trials. And the number of successes in N trials. We use X. Okay. All right. So typically we're only going to be working with 3 of these. I did want to mention how we would find Q, which is based on just 1 minus P, since failure is the complement to success. Okay, but we define it as something that has 2 outcomes, success and failure. Let me set up a scenario for us, and then we'll look at the formula. We could say, for instance, there's we know that 30% of middle college students also work full-time. And I'm making that number up, but I don't know exactly what it is. But so we're going to say 30% of the middle college students work full-time. If we select 50 students at random, what is the probability that 20 of those 50 work full-time? Okay. Now, the probability, binomial probability says that each individual student only has a 30% chance of working full-time. But it's kind of a dice roll at that point. Like it's just a random outcome. We don't know which of those 50 we're going to choose, and it could be that we know the highest likelihood is 30% of the 50 are actually working full-time. But the problem is we won't necessarily get, from a sample of 50, we won't necessarily get 30%, 15, that work full-time and then 35 that don't work full-time. We may get a collection where all of them work full-time, even though that's terribly unlikely. And it may be that none of them work full-time. We just know on an individual basis there's a 30% chance, but choosing 50 at random, it doesn't necessarily mean that we got exactly 30% outcome from that group. It could be that we picked more part-timers than usual, or people that just don't work and are just going to school, which is good, if you can do that. Or you pick more people that are actually working and going to school versus otherwise. So, I mean, that's what binomial probability helps us figure out is, how likely is this to happen? That's what probability is. How likely is this outcome to happen? That we could pick 50 students at random and have 20 of those, which is a little bit more than we expect, to be working full-time. Alright, so we have a formula, and let me say right off, we're not going to use this formula. Actually, I'm going to need to start on the next page, because the explanation of the formula is also sort of involved. So we have our binomial probability formula. And this is probability of X successes in N trials with P probability of success. And so the probability of X occurring, X successes, is equal to N factorial over X factorial times N minus X factorial times P to the X times Q to the N minus X. Now, you may be wondering, why do we have this punctuation all of a sudden in our middle of our equation? But the exclamation point, as you might have noticed, I called it the factorial. This is a mathematical operator, and what it says for us to do is when we calculate n factorial, that's the product of all the numbers from 1 to n. Okay. So if we wanted to find 4 factorial, for instance, we know that's 1 times 2 times 3 times 4, which comes out to be 24, multiplying it all together. And if we wanted 7 factorial, then we 1 times 2 times 3 times 4 times 5 times 6 times 7, that would be 5,040. Okay? Now, again, we're actually going to use the calculators to do this, not the formula. And even if we don't have a calculator, we still want to work around the formula. We actually have tables in the back of the book that are set up for us already as well. So we actually have options basically in place where we don't have to use this formula, because it's kind of a tedious calculation. What makes it really difficult is another type of problem we asked is, instead of saying, okay, what is the probability of 20 successes in 50 trials, we could say, what is the probability of at least 20 successes in 50 trials? And when we say at least 20, that means it could be 20 or more. So what we would have to do is find the probability of 20, 21, 22, all the way up to 50, find all 30 of those probabilities and add them together. And no one has time for that. Not in the 21st century. Not even in the 20th century, it turned out. Before that, we kind of had to do it that way, but yeah. So, we are either going to use the calculators, and I'll also show you how to use the table for those of you that do not have a calculator that can perform the binomial distribution. Okay. So let's set up a problem, and I'll use the example I was talking about to an extent. I'll adjust the numbers slightly. Suppose that 30% of MC students work full-time. What is the probability before we get to probability, if we choose 20 students at random, what is the probability that, let's say, 5 work full-time? Okay. First thing that we want to do is identify our values. There's 3 in particular that we went for: N, P, and X. Okay. N is the number of trials. Now, in some cases, we can create a question where it truly is a repeated trial, where maybe we have a basketball player that is shooting free throws, and they have a historical free throw percentage of, let's say 0.75, and they attempt 20 shots, and we say, okay, what's the probability that they make 5 of those 20 shots? Okay, that would be a binomial probability, and 20 attempts would be our 20 trials, because each attempt is an attempt to make be successful. In this case, it's not quite as literal, because we've chosen 20 students at random, and so we basically have to determine which, is it possible that 5 of these work full time, or how possible is that? But our 20 students will be our number of trials. It turns out that N can either represent the sample size or the number of trials, and it's equally valid in this case. So 20 is more like the sample size in this issue, or in this situation. Now, our probability of success, our probability of selecting a student that works full time is 30%. Now, we're going to make sure that we write that as a decimal, because anytime we work with probability, we want to make sure it's a decimal. And we want the probability that 5 work full time. That'll be X. X will be our number of successes. In this case, we define success as correctly choosing a student that works full-time versus not. Okay. So we want to make sure we pick all three of these values. Now, let me show you on the table in the back of the book first. This is pretty straightforward. We have n equals 20, p equals 0.30, and x equals 5. Now, in the book, we have the appendix. And if you have a physical copy of the textbook, it will basically be after chapter 15 that we get to the appendix. And the page number here is A1, so it doesn't really help us if we have the ebook. But again, like I said, it's right after chapter 15. And probably have a table of contents where you can click through to the appendix. So that's going to be helpful there. And in this appendix, part A, we have a bunch of tables. Later on, we have the answers to the odd problems, of course, like we traditionally have in a textbook, but we want the tables specifically. Now, the first tables that we have don't really need to worry about. This is the third one that we need, which is on page A3. Let's see at the bottom, page A3. Let me turn this sideways for us. I might block the camera, I'm sorry for that, but I want to show you this page entirely. Alright, so table 3, this is on the binomial probability distribution, and so across we have values for p, and we see that they're given as decimals. So 0.01, 0.05, 0.10, 15, 20, 25, 30, and we keep going by 5 up until we get to 95 on the right. It's kind of off the screen, I'm sorry. But in this case, we're using p equals 30. I had the first time. So we'll be looking at this column. However, on the left-hand side, we have n and x. Now, n starts off as 2, where x can be either 0, 1, or 2 successes. 3 trials, we could have 0, 1, 2, 3 trials, or successes of those 3 trials. And so on. And so we're going to turn a couple of pages so we get to n equals 20. 20 is actually right there. Okay. Now, another thing about this table that I would want to point out before we actually look at this problem, we'll notice that a lot of these numbers on the table are all 0.0000 with a plus sign. What that means is that the probability it basically rounds to 0, even though it's not technically 0, it's small enough that it's going to round to 0. And we'll see this more clearly when we look at this on the calculators, where we can actually see more than 4 decimal places, what it actually comes out to be. But we're going to round our answers to 4 decimal places anyway, just to match what the table is going to give us. So don't worry too much about any extra values after those 4 decimal places that we're missing here. So we'll just use what's on the table. Now, we found n equals 20. We want 5 successes, so that means we've narrowed it down to this row where x is 5. And we go across to the column where p is 30. And that looks like our value right there. You can't see the top of the page, but I found p equals 0.30 and x equals 5, and I go across and we get our value. So we get, was it 0.1789? Yes. It's a little bit of a glare, I'm sorry. So 0.1789, that's the probability of getting 5 successes and 20 students with a 30% chance of success. So from our table, we got 0.17. I forgot the number already. Where'd we go? 1789. Okay. So anyone have any questions on using this table from the book? Now again, if you have a calculator, I encourage you to use the calculator instead. That'll be much easier overall. But the table is an option, certainly. I would almost always use the table over that formula, for sure. The problem with the table is it only goes up to 20 sample size or number of trials, but I will make sure on the test that we don't have any more than that, so you can use this if you need to. Okay, so that's our table. Actually, while we still have it out, let me ask the other question. So we said, okay, we have 30% chance, or 30% of MC students work full time. If we choose 20 students at random, what's the probability that 5 work full time? And we found that to be a little bit under 18% chance of that occurring. So next question. What is the probability that at most 6 work full time? Now, sorry, I bumped out my knee. When we say at most 6 work full time, when we say at most 6, let's focus on that phrase in particular. When we say at most 6, does that mean 6 or less or 6 or more? Six or less, right. So when we say at most 6, it could be anything from 0 to 6. Good? Because it could be that 0 of the 20 students work full-time. That's not likely, but it's possible. Anything from 0, 1, 2, 3, 4, 5, and 6. Now, if we were using the formula here, we would have to do the formula with x equals 0, x equals 1, x equals 2, x equals 3, 4, 5, and 6. We have to do the formula 7 times and add all 7 of those together. And again, not a very exciting proposition. That's not how we want to spend our afternoons. So, this is where we need the table at the very least, or our calculators. Alright, but we know that we're going to do 0 to 6. Now on the table, what we have to do is we'll just, we look up our column for 30, which is right here. This is our 30s. And we'll just add up the number for 0, 1, 2, 3, 4, 5, and 6. So we'll just add up these numbers together. 0 through 6. So let me get a calculator out. I'm going to start from the bottom and work up. So 0.1916. Gosh, you can barely see that. Let me turn off the light. That might bring up the better visual quality. Yeah. It's just a little too much glare there for that. We add 0.1789 plus 0.1304, 0.0716, 0.0278, and let's see, at 1 we get 0.0068, and at 0 we have a probability of 0.0008. So adding that together, we have 0.6079, almost a 61% chance that at most 6 will work full time. Okay. And our table gave us was it 0.6079? I already forgot, and I cleared my calculator by accident. Oh well. I'll find out in a minute if I wrote that down wrong. Okay. Well, that kind of summarizes what we did. So, let's see. Let me get the book out of the way now. Alright. So the question is, how are we going to do this on calculator? Well, there's two different functions that we have to use in the calculator because this one only has one value of x and this one has a range of values of x. Okay. So for this one on the calculator, we use what's called the Binomial Pdf. And that stands for Binomial Probability Density Function. But binomial probability is the main part of that. Don't worry about the density function. And this one uses, for the calculator, we use Binomial Cdf, which is Binomial Cumulative Density Function. Now, cumulative because we're actually combining all of these together. So if we have a single value, we'll use this function. If we have multiple values, a range of values like we do here, then we'll use this function. Okay. So looking at the 36x first. It's so dusty. Anyway. If you look right above our data button, we see stat, regression, and DISTR, or DISTR, distributions. And this is like our binomial distribution that we're looking at. So we turn on the calculator first. And so we'll press second in data to bring up either our statistics, which we used before, regression, which we had also looked at briefly before, and then we arrow right to get to our distributions. Now, These we're going to use in a variety of ways, but we want to go down to where we have Binomial Pdf. On this calculator, it spells it out. On my other calculator, it abbreviates it. So I just, it might be one way or the other. So we enter Binomial Pdf, and we'll just always choose single values. We'll fill in everything here. So trials, we'll enter 20. You can see I already used this for my other class. And for this first part, we have probability is 0.30, and x is 5. So make sure we enter 0.30 for a probability, which notice it truncated it to 0.3 because we don't need the extra 0. And then we're using x equals 5. And then we calculate. Okay. And so here's the value, 0.178863051. But if we round to 4 decimal places, it's 0.1789. So the 6 there, we'll round that to a 9. So it actually gives us the same value, whether we use the table or the calculator. Absolutely, with the TI-84. I'll show you on the graphing calculator in a second, Jacqueline. And the 84, I have an 83. The 84 is kind of a combination of the two calculators that I have, and I'll mention that when I get to that. Yeah. Okay, and then for the second example we looked at, we said, okay, still 20 trials or 20 individuals, 30% chance of success, but now we want x to be 0 to 6. Now, clear that. So we'll go to second, data, go to distribution, make sure you don't click left by mistake. Now, right under Binomial Pdf, we'll find Binomial Cdf. So anytime we have multiple values, like we have 0 through 6, we'll choose CDF. Again, choose single. We have 20 trials, 0.30 chance of success. And now this time, because it's 0 to 6, basically the number that we enter here is 0 to what number, and we want 6, we'll enter 6. So 0 to 6, we'll just enter the value 6 here, and it'll take care of it for us. We press enter and calculate, and there it gives our value, 0.6080. Okay. So, not quite exactly the same as what the table gave us, but definitely we can see it's right there. They're only like 1/10,000th apart. Why do you think we would get slightly different numbers from the table than we did in the calculator? Rounding, exactly. Which is always like the main issue that we run into when our answers don't turn out quite exactly the same or where we expect them to be. It's always a rounding issue. And we have to be careful we don't try to over round things more than they already are. But yeah, the fact that they're only off by 0.0001 is no reason to be concerned. That means the table is accurate enough. Okay. Still a pretty high percentage that's happening, 0 to 6. Anyway, so that's the TI-36. Clear that. And let's look at the 83. Now for the 83 and the 84, our distribution button is actually separate from the stat button. It's over here right above where it says vars. Here's our distributions. So we turn on the calculator, and I'll clear. So we go second and then vars. And we see that we have a lot of different distributions, more here than we have in the other calculator. Now our binomial distributions are, on this calculator there's 0 and A, and on the 84s I think it's option A and B. They're off by 1, I don't remember which way though. Anyway, so we're going to select this. Now on the 83s we'll select Binomial Pdf for the first problem again. On the 84, if you have that, it'll prompt you to fill in the values just like we saw in the 36. It's much more user-friendly than 83 here. 83 though, we actually have to enter the values by hand. So enter 20 for n, 0.30 for the probability, and 6, let's see, no, that was x equals 5 in the first problem. 5, and then close parentheses. Okay, we always put n first, p second, and x third, separated by commas. We press enter, and it'll give us our calculation. And we see the exact same number that came up on the other calculator. It's 0.17886, but again, to 4 decimal places, we'll round it to 0.1789. Okay. Jacqueline, you were able to get that to work on your 84? Mm-hmm. Yeah, 84, I wish I had one because it's definitely more user-friendly than the 83s. This is just what the school provided me, of course. I don't have... I guess I could go buy one, but I don't need to carry around 4 calculators. I already have 3. 2 for stats and 1 for my other classes. Anyway, at least they're all just sitting on my desk right now. I don't have to carry them anywhere at the moment. I would prefer to have an 84 over an 83, but it really wasn't our choice. That's what they gave us, because they're probably cheaper, to be honest. Anyway, yeah, the 84, like I said, is a lot more user-friendly. For a lot of the things that we did to enter here with comma separating, the 84 prompts you to do those things instead, which is much nicer, especially from the student angle where you don't necessarily remember all the time what has to be put in there. So. Alright, let's also do, okay, second and vars, and let's do the Binomial Cdf for the second problem that we looked at. Of course, on this one we'll put 20, comma, 0.30, and again, we want 0 through 6, so we'll just enter 6. And we get 0.6080 just the same way. Okay. Now again, we have the table that we can use to look these up and then combine them together if necessary, if we have multiple ones to look at. Or we can use any of the calculators, the 36, the 83, or the 84. And again, that's why I recommended that y'all get these at the beginning of the semester, just to make things a lot easier on us. Probably you already saw that on test 1. Okay. Now, let me, before we move forward, let me switch over to the monitor here. And we go into Files. First thing you'll notice is I went ahead and uploaded Test 2 Review. And let me just add while I'm here, there is a typo where it says Test 3 Review on the actual page. don't worry about that. It is test 2, as is labeled right here. I already had one student from another class message me about that, and I admit it is confusing. The reason it's like that is I used to do 3 tests, or I split test 1 into 2 tests previously. Chapter 1 would be 1 test, and 2 and 3 would be a second test. I found that 1 is short enough, and the material goes well enough with the chapter 2 and 3 that it's easier just to put it on the same test. And it actually saves me class time for that too, because it's like it saves me a whole week of class by not having to review and then give a test for an extra chapter in there. Anyway, test will be next week. Next Wednesday would be technically when it's scheduled, although you'll have from Monday through Sunday next week. So what I wanted to show you was in the folder I've labeled formula sheets and calculator instructions. I also uploaded another document yesterday for binomial distribution. Let me zoom in a bit. So I gave you instructions for a TI-83. This is for a single value, which is Binomial Pdf, as we said. For x less than or equal to a value, or 0 through x, that's Binomial Cdf. And I went ahead and gave instructions for x greater than or equal to a value, or x to n, which uses Binomial Cdf. And we have a 1 minus in front because it also uses that complementary probability. Now, probably this one I put on the review. There's one of these on the review where you have to use this. I think I'm going to change that question on the actual test to something relevant, but not nearly as complicated. So, anyway, so that one won't be, this particular situation won't be on the test itself, even though you'll notice it is on the review. So I apologize for not being able to fix that. So we have the instructions for the TI-83. As I said, here's the TI-84 and the TI-36X. So they're all pretty similar. It's just a question of how we get to that location in the calculator, and that's what the instructions are there for. And I'll make sure I include these instructions as part of the exam at the top, like I did last time. So I'll save it as an image and then paste in that image, basically. Alright. But that's in our files if you want to look at that. Definitely check it out. Close. There we go. Anyway. I think that's all we need to do there. Let me switch back. Okay. My webcam is so slow in the uptake sometimes. Anyhow. The other thing that we want to talk about here, and it's pretty typical by this point, is we also want to figure out how to calculate the mean and the standard deviation for binomial probability. Now, this will be a nice surprise, I think. This is the easiest calculations we have for mean and standard deviation for any topic in this course. Certainly easier than anything we've looked at so far, and I don't think we need to find it for anything else after this. Our mean, defined as mu, is equal to n times p. There we go. And then our standard deviation pen's dying on me here. Just need a little bit more out of you, pen. This is the end of class. Okay. Down to my last pen. All right. Alright, standard deviation. I'm going to have to go buy more pens. Maybe I'll remember that. Standard deviation is sigma. This would be the square root of n times p times q. Okay? It's about as simple as it can get. And I'll actually provide these formulas. You don't have to worry about memorizing them or anything, just like on the other tests and future tests. Alright, so let's go back to our example where we had our MC students, where we had a sample of 20. With 30% probability of working full-time. So P equals 0.3. Right, so our mean, in this case, mu, we said it's just n times p, so it'll be 20 times 0.30. It comes out to 6. So we would anticipate on average that 6 would be working full time. Okay. And then the standard deviation, sigma is n times p times q, square root, sorry, of n times p times q. If we have a 30% chance of success, and remember q is our chance of failure, what is q in this case? Q is our chance of failure, or probability of failure. We have a 30% chance of success, so what percent chance of failure do we have? 70% chance of failure. I think some of you are misinterpreting what I was saying. That's okay. Remember, we take for Q 1 minus P. So 1 minus 0.3 which is 0.7 or 70%. Okay. All right. So we just need to calculate this. So I will take 20 times 0.30 times 0.70, which is 42, and then take the square root of 42. And so our standard deviation, that's not 42, it's 4.2, isn't it? Sorry. Our standard deviation is approximately 2.0494. I must have missed a decimal before. 20 times 0.330 times 0.70. Yeah, okay. I must have been in a weird angle. Alright, sorry about that. But yeah, it's 2.0494. Okay, so that means on average we would expect to have 6 students out of 20 working full time, but there is a standard deviation of 2.0494. In Chapter 7, after we get done with this test and the next part of the project, we're going to look a little bit more closely at the connection between mean and standard deviation and how that helps us with normal distributions in Chapter 7. So hopefully by then we'll get a little bit better understanding of standard deviation, because I know at this point in the semester a lot of students don't tend to have a great understanding of it, which is okay. As long as we're able to calculate it right now, that's all we're looking for. So, any questions? Alright, next time we're going to work on the review. So I don't have any specific homework for you. I would like for you to start, look at the review on your own. That way when we go over it on Monday next week, it won't be completely foreign to you, and you'll have an idea of what topics you are comfortable with versus what topics you need help on. I'm just going to go through the whole review during Monday's class, so don't worry about that. But I think it's good to try to attempt it first on our own. That way we can kind of see where we stand, because remember, your tests will be the same thing. You'll be working on your own. So. All right. You certainly can send me a message through Canvas, or you can email me, and I usually check those during the week at least, not necessarily on weekends unless I'm giving a test. Then I want to make sure if students are running into any difficulties that I can address them. But in Canvas you can just click on my name and send me a message that way. You also have J. Severino at midland.edu. Okay. So either through Canvas or email. If you email me directly, I may not actually read it until during the week. If you send me a message through Canvas, I have that set up on my phone to send me notifications. I don't have the email set up on my phone, so I would be cautious about that. Sure thing. All right. So anyway, look at the review, practice that, and then we'll go over it all on Monday. You all have a good weekend, and yeah, have a good rest of the day too. Take care. Bye.